Yeah, so first idea that we should try to understand is if I want to make halogen alkanes, if I want to react with them with something, how do you get halogen alkanes? How do you make halogen alkanes? And there are many different ways to do that. We'll talk about three of them. First one is free radical substitution. So basically, so making halogen alkane. Yeah, so how do we make halogen alkanes? Again, it depends on what your starting component is. Like, what are you starting with? So if you're starting with an alkane and you want to make halogen alkane, then you know that alkanes are pretty unreactive. So we do free radical substitution with them. So that's the first method. You take alkane, you add chlorine gas, and obviously you'll need ultraviolet light for this. And in presence of that, it's going to make haloalkane with HCl as the byproduct. So that's the first method. How do you extract HCl out? Fractional distillation. You will get other byproducts as well, depending on how much time you give and what's the concentration and everything. So all of those factors come into play and they give you a halogen alkane. So that's one method. We have seen this before. The mechanism by which this occurs is free radical substitution. So I hope there is no question over there. But if there is, just let me know. The second method, again, that is something that we've seen, is you start with an alkene and you take that alkene and you add any halogen in there. It doesn't have to be chlorine, it could be anything else. And what that does is it adds the halogen to the alkene. So this is addition, and this creates haloalkane. Why is this not creating haloalkene? Because this is not substitution. You are technically just adding. Now, what if I don't want to add two bromine atoms or two chlorine atoms? Like I could, so the mechanism is electrophilic addition. So an example would be if I took ethene and I added bromine. So that will give me what? C2H4Br2, because the double bond breaks and every carbon gets one bromine. But what if I don't want it to be on both the uh, carbons? If I just want it to be on one carbon, I could use an acid. I could use maybe HCl. And in that case, I will get C2H5Cl. So one carbon gets the chlorine and one carbon gets the hydrogen. I could use HBr, I could use HI. And obviously, depending on the reactivity of the acid or what compound you're using, the thing varies. So if you want it on one carbon, you add an acid hydrogen halide. And if you want it on two carbons, you add the halogen itself. And the mechanism is still electrophilic addition. We have seen this before. The molecule comes in, the electron cloud in double bond, it attacks them, and then the electrophilic addition happens. Okay. Now, when it comes to the hydrogen halides, you have to pay attention to what your major product and minor product would be. In this one, in the first one, there's no major product or minor product because both the atoms get a halogen. But in the presence of hydrogen and Cl, one of them will get Cl and one of them gets hydrogen. So you are going to get two different isomers. Okay. So you will get major product and a minor product. Now the major product, again, we can figure it out using Markovnikov's rule. Markovnikov's rule. So using Markovnikov's rule, we can easily figure out which is the major product, which is the minor product. The advantage of using a hydrogen halide, an acid, is that one carbon gets this halogen, and secondly, you're getting more quantity of one component compared to the other one. Okay, so that is the second method of making halogen alkanes. We've seen this before.
For the second one you've written, uska bhi there'll be no like major minor product, right? Like same honge.
Which one?
For the C2H4 plus HCl.
This is one example jahan pe C2H4 hai, both the carbons are identical. But yeah, what if I had, for example, if I had propene, then I am going to get major and minor product. So this will create, in presence of, let's say, HCl, one option is I will get Cl here and I will get H here. And the other option is that I will get Cl on the last carbon. Okay. Now, which is the minor product, which is the major product? It depends on Markovnikov's rule. So this is the first one. The first one will be my major product. And that's because the second carbon in there that will create it has a higher chance of creating carbocation. It's more stable carbocation, which is why it gets the more negative thing, the chloride. Of course, in the case of ethene, that's irrelevant.
Yes, sir.
Great. Now the third one is, and this is called uh, again substitution, and there are the mechanism of this substitution. I'll talk about that. Uh, maybe हम बाद में बात कर सकते हैं, चलो अभी कर लेते हैं. So what happens is it is with alcohols. Okay, so you are starting with an alcohol here, but an alcohol has 4 different ways in which it can create halogenalkane. In all of them, you're just taking the OH out and adding the halogen in there. But उसके 3 तरीके, 4 तरीके in fact. First one is if I take an alcohol and I react it with something that has halogen with a very strong, like very reactive metal. For example, I could use a halogen with hydrogen. I could use potassium halide. I could use sodium halide. Okay. Or I could also use sometimes I could use H2SO4 to help me out with this. Okay. So here's the thing. You will need, so if I'm not using acid, this HX, then I will use H2SO4 or H3PO4 to help me out with their acidic properties. So something being acid helps do this, because alcohol also has slightly acidic character. So adding an acid makes sure that alcohol doesn't behave as an acid. Okay, I need alcohol to provide me with OH, not H. That is why I add an acid. Okay, now I can use the HCl or HBr or HI itself, and if I do that, I don't need to add an external acid. But if I have potassium halide, potassium chloride, potassium bromide or something, or sodium bromide or sodium chloride or something, then I will need an acid. Now what happens in this case? So I'll give an example. Let's suppose I have ethanol. Okay, and I add HCl to it. All that happens is that this Cl goes and replaces this. And the mechanism for this, the method why this occurs, is nucleophilic substitution. Okay, and the reason that happens is because OH is a negative, it goes away as a negative, and Cl comes as a negative as a nucleophile. So that's what happens. OH goes out and HCl comes in a nucleophilic substitution reaction. So I'm left with this chlorine here, and obviously my byproduct is water. Okay, so it's a pretty straightforward reaction. If I'm not getting HCl, then for example, if I wanted to do this thing, then I will add probably sodium bromide, for example. Or if I don't want to use sodium bromide, I could use potassium bromide. But I will still add H2SO4 to act as the stronger acid. I don't want the alcohol to act as an acid. Now, in this case, I will obviously end up with this chloroethane, obviously bromoethane in this case, bromoethane. And instead of getting water, now I'll get potassium hydroxide. Okay. And yeah, that potassium hydroxide is there. And if I add extra acid, it will neutralize it to produce salt and water again. So I don't really get any harmful byproducts that damage my reaction. That's one method. That's nucleophilic substitution. If I don't go with that, then I also have other options. And in these options, I break OH into 2 parts. I don't take OH as a whole. I take the alcohol's OH, I break it down. I take the H out, I take the O out, and the rest of it out. So basically, in this case, what are we doing? Right now, we are breaking the alcohol into 2 parts. We're breaking it here. But in the other 3 methods, we will not just break it here. We will also break it here. And through those method, and there are three of them, we will be able to make halogen alkane. Okay, so let's see what happens. So the first method is that I use an alcohol, obviously, with PCl3, potassium, phosphorus trichloride. Now, what happens? You have to understand that you have 3 chlorine in it, and they will all react. Okay. So the first thing that happens, for example, if I had this one, and I added PCl3. Now pay attention. I'll open it up. So P with 3Cl. So 1Cl goes with the hydrogen. Okay. And the other two, यहाँ पे बल्कि इसकी जरूरत नहीं है, हम इसके बगैर इसको कर सकते हैं. What's going to happen here is that the chlorines are all going to attack the OH, and you're going to get this. यहाँ पे हमें उसकी जरूरत नहीं थी. And this phosphorus is going to break hydrogen and oxygen separately, and it's going to come up with this compound H3PO4, phosphoric acid. Sorry, 4 तो नहीं बन सकता because I'm getting 3. तो इसको समझने का, let's start over. What happens is that I have PCl3. So all the Cls go and replace OH, okay? And then I have what? POH3. But POH3 doesn't exist as POH3. It's not phosphorus trihydroxide or something. It doesn't exist. It breaks down. It rearranges the compound. And what happens is there's a rearrangement, and you end up with 3 hydrogens separately and PO3 separately. Again, the method is really
what
simple.
happened to the other 2 chlorines?
We balance it out. Here's what happens. PCl3 is this compound, right? Now, these chlorines have to be just replaced one at a time. So the first one goes away, gives you an OH. The second one goes away, gives you an OH. And the third one goes away and gives you an OH. Now, because the bond between hydrogen and oxygen is very polar, this has become a weak acid. So you are going to get this chlorine replaced with OH, but in this case, what's happening is that it has basically created a new acid, okay? And this acid is a weak acid. All right. Now, the third method is the one that I was talking about. Sorry, I confused the two. I take the alcohol and it reacted with PCl5. Now, what does the PCl5 do? It breaks the alcohol from 3 different parts. Okay, so I'll take an example. I have ethanol here, and I have phosphorus with 5 chlorine. So the 5 chlorine works like this. There's 3 of them in the same plane, one above and one below. The bond angles here are 120 and the bond angle here is 90. So the one above and the one below are going to react differently than the ones that are in the same plane. Okay, so here's what happens. The one above is going to react with hydrogen, one of them. So one of them is going to react with hydrogen, and you're going to get HCl. Another one is going to go and replace the OH, okay? And you're going to get CH2 with C2H5 with a chlorine, okay? And that oxygen in there is going to come, and now it's going to, so ये chlorine इधर आ गया इस पूरे की जगह पे, और ये chlorine H के साथ चले गया, okay? इसका पूरा एक mechanism होता है, but we don't need to go into that. अब आपके पास बचा एक oxygen, and what that does is it basically creates, one way to think about this is that the 2 chlorine went out, one reacted with hydrogen, one reacted with carbon, and oxygen replaced both of them. So it creates POCl. And then we have one, ये समझ आ गया? 2 chlorines replaced with 1 oxygen, and वो दोनों क्या करते हैं? एक carbon के साथ चले जाता है, एक hydrogen के साथ. The fourth method that we have is actually the one that we use the most. And that is I take C2H5 at the alcohol and I react it with SOCl2. This method is always preferable to the method of PCl5 because this is much cleaner. Okay, so I'll explain in a bit क्यों ऐसा क्यों होता है. Let's suppose I have ethanol and the reactor with SOCl2. Again SOCl2 मेरे पास इस तरह से molecule है. One chlorine, you can see that this is going to behave very similar to this one, PCl5. One chlorine goes away and reacts with H, making me HCl. The other chlorine goes away and reacts with carbon, giving me ethyl chloride. And the oxygen comes and replaces both of them. So I'm left with SO2. As you can see, of course, it's got
So which H does the first chlorine react with?
this hydrogen, always.
And then the other one replaces the oxygen.
Yep. And that oxygen comes and replaces both. Okay. So, yep, that's what we get. This method is clean because it's producing two gases. It's producing this gas, HCl is a gas. This is not a gas, this is dissolved in whatever solvent you have. And this is also a gas. So each of these methods has its disadvantages. Advantages. This one is clean. Does not produce any byproduct that we need to remove manually. Because gas बनती है, bubbles होते हैं, वो खुद ही बाहर निकल जाते हैं. We are left with the compound that we were looking for. This method has an advantage that this is happening at room temperature. I don't need to heat it up. And this method, I will need to heat it up and I will also need to do fractional distillation to separate them. So that's how I get these tertiary or secondary or primary, जो भी मेरे पास बनते हैं, halogen alkanes. Okay. So that's how I get them. That's 5 different methods, 5, I think 6 different methods of making them. Alkanes, free radical substitution, we know it. Alkenes, electrophilic addition, we know it. And alcohols, 4 methods. And we will review these methods later on when we study alcohols as well. And we'll try to understand why this is happening. But with alcohols, you can either take the whole OH minus ion and replace it with chlorine right away. And that's nucleophilic substitution. We do it in presence of an acid. Or you can just take one of these 3 things, PCl3, PCl5, or SOCl2. And they will do their job, providing you with halogen alkanes. In all of them, you get halogen alkanes. Okay, now I've gotten the halogen alkane. What can I do with it? So halogen alkanes have many different properties. Of course, इनका सबसे बड़ा फायदा जो है ना, like people discovered them in 1930s, and most of them are unreactive. And people were really happy with that. This is a molecule that doesn't react that much, and these are gases. They are inert, and you can use them. You can use them. For example, हमारी body है और हमारी body में कोई भी हम कोई gas inject करते हैं, so we don't want it to like damage the functions of the body, and obviously हमारा aqueous होता है हमारी body के अंदर सारा, so we don't want it to react with water in there as well. And these are perfect for that. They don't react with water right away. They don't मतलब room temperature पे या हमारी body में कुछ भी नहीं करते, and we do find them useful as anesthetics. So हम इसको as an anesthesia use कर लेते हैं, and this was such a remarkable product for that. कि बंदा बेहोश होता है, थोड़ी देर बाद होश में आ जाता है, आप उसके दौरान उसकी सर्जरी कर सकते हैं, एंड उसकी बॉडी को कोई नुकसान नहीं होता, कोई लॉन्ग टर्म उसके इफेक्ट्स नहीं होते, because it doesn't go into the body and react with different things. It just doesn't do that, which is good. It's a miraculous compound for that. Then you use them in aerosol sprays. आपने smell अच्छी बेचनी है, but that smell particle needs to dissolve in something. Dissolve it into this thing. It won't react with it. Spray करो, वो ये उड़ जाएगी, और the smell goes around in the room. Very good. Aerosol sprays. You need to compress some gas that doesn't react in refrigeration. Sure, use this gas. This gas goes in, you compress it, it doesn't react. और घर में अगर लीक हो भी जाती है तो किसी की बॉडी को कोई नुकसान नहीं है क्योंकि it doesn't react. So बहुत useful compounds हैं, and they were used as refrigerants, as aerosol sprays, as to be used as anesthesia. And then people figured out, wait a minute, they don't react at room temperature, they don't react in our bodies, but they do react in other conditions. and they are damaging our bodies in very different ways because they were damaging ozone. Because ozone is in our upper atmosphere, it's a very thin layer, and they are reacting with ozone. They're breaking it down into, they're converting it to oxygen gas from O3, which means it won't be able to stop the sun rays, which will come in and it will cause skin cancer or something. And now they're pretty much banned. Halogen alkanes is used as refrigerant or aerosol, or they are banned in most developed countries. But we still haven't found better anesthesia compounds. So we use, for example, uh, what we do is we try to use compounds जिनमें ज़्यादा strong bond हो, जैसे फ्लोरीन की bond. हम क्लोरीन वाले मॉलिक्यूल नहीं लगाते. क्यों? Ozone depletion का primary culprit is chlorine. Chlorine is responsible mainly for ozone depletion. Why? Because in the upper atmosphere, ozone ultraviolet lights can damage the chlorine carbon bond. It's a weak bond. But chlorine fluorine carbon fluorine bond is very strong, which is why we can still use halogen alkanes which have fluorine in them. So usually जो अब anesthesia के compounds use होते हैं, they are the ones with fluorine in them, with hydrogen in them, not chlorine. ठीक है, so that's one use. But अब हम इनको और जगहों पे react कर सकते हैं. If we heat them, they will react. और इनका एक बहुत ही जबरदस्त यूज है जो हमें मिला है, and that is that they're used to elongate carbon chain. मतलब मैं आपसे कहता हूँ I have a 2 carbon molecule but I want to convert it to a 3 carbon molecule. So you can use halogen alkanes for that. क्यों? Let's suppose I have ethanol and I want to convert this ethanol to propanol. I won't be able to do it. क्योंकि मैं कार्बन कहां से ऐड करूं? Ethanol has OH in there. इस OH को तो कोई, ये OH नेगेटिव है, इसको कोई नेगेटिव चीज ही रिप्लेस कर सकती है. It's a nucleophile. I can only replace it with another nucleophile, but carbon is not a nucleophile. But what I can do is I can replace this OH with a bromide or a chloride or a fluoride. और जब वो हो जाएगा उसके बाद मैं उस फ्लोराइड को रिप्लेस कर दूंगा किसी और कार्बन वाले मॉलिक्यूल से. The problem with the OH, तो अब यहाँ पे सवाल आता है अगर आप फ्लोराइड को कर सकते हो वो भी नेगेटिव है तो why not OH? इसको डायरेक्टली कर लो. The problem with this reacting directly is कि ये as an acid react करना शुरू कर देता है. So we don't use this. So what we can do is we can first replace this this OH with some bromide, some chloride, और उसके हमने मेथड देख लिए. We have these 4 different methods of converting an alcohol to halogen alkane. अब मेरे पास halogen alkane बन गया. Let's suppose bromine है यहाँ पे. And now I want to elongate the carbon chain. I will react it with a compound with this ion in it, the cyanide ion. Cyanide ion is basically carbon with triple bond with nitrogen, and carbon has a lone pair because nitrogen is making a dative bond with it. Okay, so carbon has a lone pair and there's a negative, and nitrogen also has a lone pair. So हमारे पास ये एक बड़ा जबरदस्त मॉलिक्यूल बन जाता है. It's an ion, of course, molecular ion. Where do we get it from? We can get it from carbons, potassium cyanide, sodium cyanide, or hydrogen cyanide. Okay, so I can use them, but I can't use water because if I had water, then water will provide OH, which will come and replace Br. मेरा सारा काम खराब हो जाए. So what do? I dissolve them. No matter which one I choose, I need to dissolve them in ethanol because ethanol will make sure that it doesn't react with, it doesn't come and replace Br. क्यों? क्योंकि Br itself replaced OH. तो Br OH को replace कर सकता है, OH Br को replace नहीं कर सकता, OH Cl को replace नहीं कर सकता, OH फ्लोराइड को रिप्लेस नहीं कर सकता इस वक्त. ओके, सो साइनाइड कैन रिप्लेस हेलोजन एंड हेलोजन कैन रिप्लेस OH. हमारे पास एक रिएक्टिविटी सीरीज बन रही है इनकी. So I will dissolve them in ethanol and now ethanol will act as my solution in which they react. in which they're able to move around and collide. Otherwise मुझे इसको evaporate करना पड़ेगा. I don't want to do that. That takes a lot of energy. तो मैं इनको move around करने के लिए, because these are solids, I dissolve them in ethanol. In ethanol, cyanide ion is provided. This cyanide ion comes in, does nucleophilic substitution. We have studied nucleophilic substitution yesterday. So हमारे पास bromide की जगह पर cyanide आ जाता है, and the bromide goes out. And of course, if you're using KCN, it will produce KBr. If you're using HCN, it will produce HBr. If you're producing NaCN, it will produce NaBr as a byproduct. The importance is that we have elongated the carbon chain. मैंने यहाँ पर carbon.
What will the byproducts be?
Depends on what compound you started with. If you started with HCN, this bromide will go and replace. देखो ना, if I replace this with Br, I'll get HBr. If I replace this with Br, I get NaBr. If I replace this with Br, I get KBr. So it depends what compound you started with. The the cyanide ion in there will be replaced. So in inorganic chemistry, this ion is called cyanide. But in organic chemistry, this is called nitrile. Same thing, CN. So now this compound, right now, this is potassium cyanide and sodium cyanide or hydrogen cyanide. Potassium cyanide is, by the way, the main poison in जो king cobra नहीं होता, उसके जो venom होता है, उसके अंदर mainly ये होता है. ये हमारी nerves को बहुत ज़्यादा damage कर देता है in a span of a couple of seconds. It's really dangerous to use, especially if injected into the bloodstream. Now, this compound is called propane because there's 3 carbons in there. Nitrile, because in organic compound CN is called nitrile. इसका मतलब ये हुआ कि मैं ब्रांच भी बना सकता हूँ. अगर मुझे elongate करना है, मुझे ब्रांच बनानी है, मैं उसको बड़े आराम से बना सकता हूँ. For example, I'll give you an example. Let's suppose मेरे पास ये 3 कार्बन हैं और यहाँ पे OH है और मैं कहता हूँ मुझे यहाँ पे ब्रांच बनानी है. तो मैं सबसे पहले इस OH को रिप्लेस करूंगा किसी भी हेलोजन के साथ. So for example, I could use bromide here. So I do nucleophilic substitution. OH is taken out, bromine is coming in. I have 4 different methods of doing this. And now I can react it with KCN, for example, and it has to be ethanolic. It must be dissolved in ethanol. And now what happens? I am going to get a CN here, and I have just created a new branch of carbon. Of course, there's a byproduct made. Potassium bromide बन जाएगा. अब इस नाइट्राइल के आगे कुछ रिएक्शन है, 2 रिएक्शन है, लेकिन I don't want to go into that for now. मुझे इसका फायदा हुआ है, मुझे इसका फायदा ये हुआ है कि मैंने एक नया कार्बन ऐड कर दिया, and this helps in making new compounds, especially in whenever you want to make medicine. You start with one compound, उसमें चीजें ऐड करते जाते हो, उसकी chains बनाते जाते हो, and ultimately you end up with some compound that you really wanted to make. और हम उसको देखेंगे. This will start making sense later on as well कि क्यों ये इतना important क्यों, ये वाकई बहुत important है, मजाक नहीं है. This small act of adding 1 carbon to the chain is super important. Why can't I use it directly with OH? Because OH जो है वो as an acid भी react कर सकता है. But what I do is कि I replace OH with the halogen and then halogen with the CN. तो मेरा काम आसानी से हो जाता है. Okay, halogen alkanes also react with ammonia. Basically anything that can provide a nucleophile ना, halogen alkane उससे react कर जाएगा. तो अगर मेरे पास halogen alkane है, and again halogen alkane always needs to be heated क्योंकि वो वैसे react नहीं करता, inert होता है, आपको पता है. So halogen alkane में let's suppose मेरे पास ये है और chlorine है और मैं इसमें ammonia ऐड कर देता हूँ. The thing with ammonia is that ammonia molecule, इसको भी समझ लो, that ammonia can be broken down. Sameem, बस ये last पढ़ लो. Ammonia molecule is interesting because you can break ammonia into many different ways. इसमें ना polar bond होती है और जो भी polar bond होती है वो आप nucleophilic उसको आप break कर सकते हो through heterolytic fission. तो होता क्या है कि आप इसको इस तरह से break कर सकते हो कि ये दोनों ये यहां से टूट जाए, ठीक है, और उससे क्या हो कि आपके पास NH2 माइनस बन जाए और हाइड्रोजन आयन बन जाए, हाइड्रोजन आयन बन जाए और NH2 माइनस बन जाए, क्योंकि इसके पास लोन पेयर आ जाए। आप इसको तोड़ सकते हो हेटेरोलिटिकली। सो उससे होता क्या है कि आपके पास जो NH2 आएगा ना, वो Cl को रिप्लेस कर देगा और H किधर जाएगा, Cl के साथ। एंड यू विल सी अ पैटर्न हियर, जिस जिस कंपाउंड में न्यूक्लियोफाइल निकल सकता है ना, वो न्यूक्लियोफाइल आके Cl को रिप्लेस कर सकता है। तो अगर वो HCN है तो CN आ जाएगा। अगर वो अच्छा, इनका ऑब्वियसली सब्स्टिट्यूशन वो भी हो सकती है कि आप HCl में HF डालो तो फ्लोरीन आ सकता है, आप C2H5Br में HCl डालो तो Cl इज मोर रिएक्टिव, उसको डिस्प्लेस कर सकता है अगर वो उससे निकल आए। बट विल टॉक अबाउट which one reacts faster, which one reacts slower later on. आपने ना ऑर्गेनिक केमिस्ट्री में इंडिविजुअल रिएक्शंस पे उतना फोकस नहीं करना है, आपने देखना है कि इज देयर अ पैटर्न देयर। जैसे यहां पर इसके सब रिएक्शन में एक पैटर्न है, anything that can provide a negative ion, a nucleophile, will react with halogen alkane. At obviously you need to heat it, and when it does react, वो उसको सब्स्टिट्यूट कर देती है, न्यूक्लियोफिलिक सब्स्टिट्यूशन। एल्केन्स में हमने देखा था कि जिस चीज में पोलर बॉन्ड है या वो पोलर बॉन्ड बना सकती है, वो आके उसको डिस्प्लेस कर देती थी, डबल बॉन्ड को तोड़ देती थी। और एल्केन्स में हमने देखा था कि जो चीज फ्री रेडिकल बनाती है, वो उसको आके हाइड्रोजन को डिस्प्लेस कर सकती है। सो दोज आर द पैटर्न्स। इंडिविजुअल रिएक्शंस को नहीं देखना, अदरवाइज यू विल बी लॉस्ट इन अ मिरियड ऑफ रिएक्शंस। इतने ज्यादा रिएक्शंस, इतनी ज्यादा रिक्वायरमेंट्स होंगी कि आप कहोगे मेरे से तो केमिस्ट्री हो ही नहीं रही है। दैट इज द मिस्टेक मोस्ट स्टूडेंट्स मेक। आपने इंडिविजुअल रिएक्शंस को याद करना ही नहीं, आपने अंडरलाइंग प्रिंसिपल्स को आइडेंटिफाई करना है। मतलब यहाँ पे मैं पोटेशियम साइनाइड क्यों डाल रहा हूँ, क्योंकि पोटेशियम साइनाइड इज अ पोलर मॉलिक्यूल, सॉरी इट्स एन आयनिक कंपाउंड जिसमें बहुत स्ट्रॉन्ग नेगेटिव और पॉजिटिव चार्जेस हैं। तो मैं साइनाइड उठाता हूँ और मैं क्लोरीन की जगह डाल देता हूँ, ब्रोमीन की जगह डाल देता हूँ, और यही काम मैं बाद में अमोनिया में भी कर रहा हूँ, क्योंकि अमोनिया को भी मैं ब्रेक कर सकता हूँ। I can take the NH2 minus ion out and H positive out. So I can make ammonia react as an acid. And this is a very interesting thing because I just made ammonia react as an acid, provide me with H positive. और ये सारे के सारे पानी में नहीं होने चाहिए, वरना OH माइनस भी आ जाएगा। I don't want that. वो अल्कोहल बना देगा, मेरा काम सारा खराब। तो सारे के सारे एथेनॉल में डिसॉल्व होने चाहिए, और ये सारे के सारे रिफ्लक्स में होंगे, क्योंकि हेलोजन एल्केन्स आर वॉलेटाइल, वो उड़ जाते हैं। तो ये सारे के सारे रिफ्लक्स में होंगे। तो अंडरलाइन प्रिंसिपल्स को अगर आप समझ लो ना, आपके लिए पूरे पूरे चैप्टर्स 3 या 4 लाइनों में आप समराइज कर सकते हो। पूरा एल्केन्स का चैप्टर आप कह सकते हो भाई फ्री रेडिकल सब्स्टिट्यूशन होती है, कंबशन होती है, बात खत्म। फ्री रेडिकल का काम मैकेनिज्म आ जाएगा। एल्कीन्स के 4-5 रिएक्शंस हम एक लाइन में कह सकते हैं कि भाई इलेक्ट्रोफिलिक सब्स्टिट्यूट, इलेक्ट्रोफिलिक एडिशन होती है, जो डबल बॉन्ड है उस पे डीलोकलाइज इलेक्ट्रॉन्स हैं, जो चीज पोलर बॉन्ड लेके आएगी वो रिप्लेस करेगी, रिएक्ट करेगी। और यहाँ पर हमारे पास क्लोराइड है, ब्रोमाइड है, फ्लोराइड है, whatever halogen you have, it is going to go out as a nucleophile, as a negatively charged thing. So anything coming in with a negative charge will easily replace that. Okay.